Problem number 5. We have a environmental experiment taking place where we have a factory that gives off smoke, and they want us to collect that smoke given off, or that gas is given off, in a collection balloon. Now, I could not find a clip art with a smokestack with a collection balloon attached to it, so thus my lovely drawing there. They tell us that the gas is made up of sulfur dioxide gas, nitrous monoxide, or nitrogen monoxide, and sulfur trioxide. And they give us gram amounts of each one of those. And they want to know what is the mole fraction of each component in the mixture. When I see the term mole fraction, this formula pops up into my head, like what we worked on with the worksheet, where X is the mole fraction equal to the individual mole amount of a particular gas divided by the total moles. Well, our problem here is they give us everything in grams. So we need to go through and convert each one of these gram amounts to a mole amount. So starting off with our SO2, we know that 1 mole of sulfur dioxide weighs 64.1 grams of SO2. Just pulled that off of my periodic table. Remember, when we're going from grams to moles, or in this situation, grams to moles or moles to gram, either way, we need to use the periodic table. And so when we divide that out, we should get a value of 0.234 moles of SO2. All right, go through the next one, 1 mole of nitrogen monoxide, and that weighs 30.0 grams. So we divide that out and we get a value of 0.403 moles of nitrogen monoxide. Great. Go on to the next one. We know that 1 mole of sulfur trioxide weighs 80.01 grams. We divide that out. Make sure you recognize, our gram units cancel out in each one of these. So we end up having an answer in moles, which is what we need. And when you divide that out, you get 0.031 moles of SO3. Not very much, obviously, compared to the other ones. Now, to be able to determine the mole fraction, we need to have the total amount of moles. So we're going to go through here and add those 3 values together. Remembering when we're adding and doing our sig figs, we can't have any more place values than the least amount in any of one of our components. So 3 place values, 3 place values, 3 place values. We should have 3 place values in our final answer, which is 0.668 moles. Okay? Great. Now we know what the total amount of moles is. So we can go back here and take our 0.234 mole amount, divide it by our 668 moles. And because we're talking about a mole fraction, we should not have, it's like a proportional value. We should not have any units attached to it. All right? And we get an answer of 0.350. I'm sorry if this is looking fuzzy. I'm trying to write clearly for you. Do the same thing for here. We're going to take our individual mole amount, divide it by the total amount, see where our units, moles cancel out, and we should get 0.603. Perfect. And for the last one, obviously it's going to be a smaller amount because we have a smaller mole amount there. So our 0.031, oh my goodness, that arrow looks hideous. Sorry there. Eek. And we divide by our total amount again. So we're just redoing the step 3 times, see how our moles cancel out, and we should get an answer of 0.046. All right. That's what you need to have, 3 different numbers. Now, I want you to think about, if we're talking about like a percentage or a proportion, what should these 3 values add up to give us our total? All right? Any ideas? They should add together to give us 1, or like 100%. But in this situation, we're going to keep out, since we're dealing already in a decimal value, they should. So let's see. Now, considering we did some rounding here, we're only getting 9, but 4 and 5 is 9, 6 and 3 is 9. So we get 0.999. If we'd taken it out to a farther decimal place, we obviously would have had exactly 1. But the idea is because we are dealing with individual mole fractions, the mole fractions of each one, they should completely add up because 100% of the gas is of these 3 individual gases to 1. But the answer I am looking for you guys to have is this one, and this one. So this whole problem is going to be worth 3 points. Okay? All right, thank you.